Hi, in this video we're going to be trying to fix up this Divoom Pixoo 64, and what it is, it's a digital display that can display things such as cryptocurrency counters or how many days to Christmas, social media account stats, YouTube counters, all that kind of stuff. So I purchased this one off eBay for spares or repair, and the seller said that he was using it for displaying his YouTube stats when one day the screen just wouldn't come on and stayed blank. All he gets is a red power light and that's it. So we'll get it out of the box, and while I'm doing that I'll show you the one that I've got, because I've got one of these already and I use it as a YouTube counter myself. Right, I've got it out of the box. Let's just plug the power lead in. You can see the red power light on there. Let's just give it a moment to boot up or whatever. And it's not doing anything. Just a completely blank screen. Right, let's take it apart and we'll see if we can figure out what's up with it. And it looks like we've got a number of screws around the outside of the frame here, so I'll just remove those. Right, that's all the screws out of it. Now it looks like we've got some ribbon cables or something down here. Looks like we've got a power cable and a ribbon cable going over to this little back board here. So let's see if we can disconnect those for the moment. That's one cable disconnected, and that's the other. Right, let's zoom down a bit on this. So I think that must be a little speaker or something maybe there. I think that says Buzz 1. Looks like we've got a little microcontroller just at the left there. Yeah, Giga device GD32F303 or 303. Looks like we've got quite a few line or display drivers there. I can't see anything blown. So that looks like the Wi-Fi antenna there, and that looks like it goes onto this board here. So I think we'll get that one out next. Get the plastic bit out of the way. And we have a little expressive chip there. I'm just trying to see which one it is. There we go. So it's an ESP32 Rover IE. A little voltage regulator there. A little SD card slot with an SD card in it. Let's have a look at that. 512 meg. Let's see, we've got a little inductor here and a few transistors. So what I might do then is plug this back in, connect this little board back up, we'll connect it back up to the power, and then we'll see if we get voltages and things on this voltage regulator. Just put the board on a plastic bag here just to insulate it. Let's just plug it in, and there's a little power light lit up there. Let's just see what we get on this voltage regulator. So 5 volts there, 3.3 volts there. So that looks okay then. So we're getting 5 volts in, and that's regulating it down to 3 volts. Unless the brains is running but the display isn't. I'll just see if I can zoom out a little bit and we'll just try measuring. Because this looks like the power connector for the display here. So if we use this as a ground, and it looks like we've got 2 ferrite beads there. I don't seem to have power. Let's just try one of the capacitors on one of these logic chips here. Just try directly across one. So it appears that we're not getting any power to the display here. I'll just zoom down a little bit. I'll just see if I can get the meter in shot at the same time. Let's just try one of these chips here. So we don't appear to be getting any voltages. So I wonder if the problem's on here then, that it's not supplying the voltage to the actual display panel. Let's get this under the microscope and we'll just have a quick look over the board just to see if we can see anything obvious. Right, let's have a look over this board then. So this is the voltage regulator. So that's where the 5 volt comes in. And I think the 3 volt must come out here and then go up to this pin here. A little SD card slot. I'm not sure what that's for, whether it's firmware possibly, or whether it's images or something like that. So this is the connector that powers the display. It looks like the 2 pins in the middle aren't used. This appears to be ground and this appears to be the 5 volts. So that seems to come from these 2 MOSFETs here, which then comes to here, which then comes to here. And we've got a, looks like an inductor here, just for filtering perhaps. So let's see if we get continuity from the USB socket to where these MOSFETs are. So I'll just go on to resistance. Let's just go from this point here. Okay, so it goes to there. We haven't got a shorted cap or something, have we? Nope. I was just wondering if that cap had gone short, whether that would obviously stop the power from getting to the display. Let's just go on to diode check and we'll just check this diode here. That's okay. And none of the MOSFETs are shorted. You have another transistor here. That seems okay. Let's check this transistor up here. That seems okay too. Let's just check the soldering on this ESP module, just in case there's any problems with that. I'll just get this cable out of the way. That looks okay. Let's check the other side. And that looks okay too. I don't think there's much on the other side of the board. Mark II, Mark IV. Looks like we've got a footprint for a little switch there. So I wonder if that's for putting the ESP into programming mode. And it looks like we have a header here, which is probably used for programming, some kind of serial by the look of things. So I might pop this SD card out, try that in the computer just to see if that's got anything to do with it, because you never know. If the SD card's failed, I wonder if that would stop it from booting up. So I'll go and try this on the computer. So not the SD card then. And if it does cause problems, they say just to blank it. So let's just try plugging it back together. We'll try seeing if we can do a factory reset, because it said hold the power button down for 20 seconds. And we'll see if that does anything. Hold the power button down while we're plugging it in. And it's still completely blank. I wonder if we're getting any data on this connector here. I'm trying to think whether to put the scope on or just try the thermal camera quickly. I might try the thermal camera. We'll just see if anything's getting hot, just in case there is a short that's pulling the fire. I don't think there is though. Let's just have a look. Right, we've got the thermal camera out. And it's getting very slightly warm on the voltage regulator. And nothing else by the look of things. Just the voltage regulator there. Well, that didn't reveal anything. I'm going to hook the scope up and we'll just see if we get any data or anything on any of these pins when we power it on. I've got the scope hooked up, so what I'm going to do is just try going on one of these test pins here, and then we'll just power it up. So I've just got a constant voltage on that one. Let's try this one. Nothing on that one. And nothing on that one. Can't see. Actually, there's some more test points up here, but then again, if this board isn't getting any power, that MCU isn't going to be powered. Let's see if anything toggles on the base of this transistor. So I'll just go on to there, and then I'll just plug it in. Nope. Let's try that again. So it doesn't look like this is processing or something, because we're not getting any data on this connector here, and also it doesn't seem to be switching this transistor on. Tell you what, let's just unplug it a moment. Let's have a probe on these connections here. I'll just zoom down a little bit more. So let's see if we get anything on TX. So I'll just power it up now. We are getting something there. It seems to be spitting data out on that pin there. So it looks like it is actually doing something. We're not going to get anything on RX. Let's just try these pins. Strange. So nothing on that one. Looks like we've got a bit of a dip in the middle of that one. That looks a bit strange. But we are getting some data on the TX pin. So it looks like the brains of it's working, but it's not actually doing what it's supposed to do. I don't know what any of these other test pins are. Let's just have a poke on some of those. So what I might do next then, I might hook this up to the computer. We'll tack a couple of wires onto these pins here, and then we'll have a look on the computer to see exactly what messages it's chucking out. It might give her a hint of what's going on. I've soldered some wires onto these header pins here, so it's easier to connect to the serial UART. And I've just tinned those pads here, so let's solder the wires on. So I've got a ground wire to go on first. Yeah, that should do for those. So let's take it over to the computer now, and we'll see what messages it's spitting out. This is the serial to USB adapter that I've got, and I've just got to connect it to the board here. So we just need to plug this into the computer with the USB lead here. So that's it plugged into the computer there. You can see we've got a little light on it. So we'll jump over to the computer screen, and we're going to use this program here called Putty. And what it is, it's like a terminal. So what we're going to do, we need to use serial port, but I need to find out what serial port that we're on. So if I just go to device manager here, and that's it, our USB serial port is on COM6. So I'll change this to COM6, and we'll go 115/200 for the speed. So there's nothing happening at the moment because I need to plug the power in. So let's just do that now. So we'll just plug the power in here, and we can see some data, and it seems to be repeating over and over and over again. Let's make this window a little bit bigger. I'm just going to switch the power off again a sec. What it says here, invalid header. So it looks like the system can't boot because it can't read the flash memory properly. Let's try unplugging the SD card and see if that makes any difference. So I've just unplugged the SD card there. Let's just plug that in again. And it seems to be doing the same thing. So this looks like it's got a problem with the flash memory. So I need to get it into programming mode, and to do that we need to operate this switch here. However, there isn't a switch there. But I do have a set of switches that were for key fob remotes for cars. And I think this one here looks like it'll fit just perfect. So let's get it under the microscope and we'll get this fitted. Let's add a little bit of solder first. I'm just going to spin this round and then we'll solder the other side. And I think that should do. So we have our little button fitted now. So what I'm going to do is hold the button down while powering it up, and we'll see what happens on the computer screen. I'm waiting for download. So it looks like we can program this, but I wonder if we can actually read the flash. So I've downloaded a program called ESP Tool, and that's it there. So let's just try ESP Tool and see what commands we have. So we've got basic commands here. We have write flash, read flash, erase flash, and flash ID. So let's try flash ID. So we'll just go over to the board, and what I'll do, I'll just reset it and hold the button down here. And let's see what that does. So it looks like this has a 16 megabyte flash. Manufacturer and device. And it's using 3.3 volts for the flash voltage. Right, I'll see if I can figure out how to dump 16 megabytes of flash now then. So I've figured out the command that we need to use to dump the flash, and it's this command here. That's the start byte, which is 0, and that's the end of 16 megabytes in hex, and we're going to dump it to a file called firmware-dump.bin. So let's just press the button again, and we'll just reset this. Like so. And let's see if this dumps the flash. And it seems to be reading it indeed. Excellent. So I think we'll come back when this is finished. Looks like the little communication lights flickering away there. And that's it. It seems to have read the flash to a file called firmware-dump.bin. So let's have a look at that. So I'm going to use a program called Ultra Edit here, which I used a fair bit. So let's just have a look, see if there's anything in this flash. Well, it all looks zeros at the start. Let's just scroll down a bit. There's a little bit of data there. And then a block of blanks. And here we've got something here. We've got some data starting here at 1000 in hex. I can see some text strings in here. Watchdog reset, home, Albat, work, ESP Divoom. So it looks like there is some data in this flash chip. I'll just scroll down a bit more just to have a quick fly through it. So there's data in there, but there must be some kind of corruption somewhere. At the end of it here, we're just all FF, which is just blank. That appears to be about half of the chip. Yeah, exactly half of the chip. So it only looks like 8 megabytes of the chip is actually used. And the other 8, the top 8 megabytes, just blank. So I thought I'd do a little bit of a search to see if I could find what addresses are used in the flash. And it says there's a partition table here at 8000 and the bootloader starts at 1000 and factory application at 10,000. So let's have a look, see if there's a partition table at 8000. So and indeed it looks like there is. So it looks like we've got NVS, OTA data, init, OTA 0, OTA 1, and then storage. So I guess storage is probably for things like images and that and stuff. OTA 0 and 1 might be something like the application and a backup application. I think PHY init, I think that's for data to do with the radio and that stuff. I'm not 100%. I'm not sure what OTA data is. So we do have a partition table. So I thought I'd ask Google if it could decode this ESP32 partition table for me. So I pasted it in and it said yes, it's a standard partition table. And it gave us all of the start and end addresses here. So OTA 0 is the actual application. So what I'm going to just do now, I'm just going to try and dump that. So I've just got the command typed in here. So I'm just going to reset it again. Let's just plug this back in again with the button pressed and hit enter. So we'll dump this and then we'll try running the image info command on it.
A few moments later.
Nearly done. And that's it. So ESP tool image info OT. We'll see what it does with that then. Okay, So it says the checksum here is valid. It tells you the project name here, Pixoo 64 Wi-Fi. So that part actually seems okay. Interesting. So the actual main program seems okay. So I think I found something. So if we look here, OTA 1, which is the copy, the second copy of the application, starts at 290,000 in hex. So if we go there, we can see there it starts E9 blah 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 blah. And E9 is a magic number, so it has to start with E9, otherwise it means it's invalid. So if we go to OTA 0 here, which starts at 10,000, so if I just copy that, and we'll just go to there, we can see that one there also starts at E9. So any applications that run must start with E9. That's like their header. And the message that we were getting on the PuTTY serial output was invalid header. And I can't see any boot messages here, like any sort of bootloader messages. So if we go to where the bootloader is, so if we just go back to here, the bootloader starts at 1,000. So I'll just go back to the flash dump here, Control G to go to, and we'll go to 1,000. This is starting E8, not E9. And also something else that I've noticed, it says here like load, and this should say partition, but it says partition with a J at the end instead of an N. And then we've got, I think that's supposed to be table error, but it's got a D there instead of an E. Yeah, so it's supposed to be table error like that. And it's actually 1 bit off, and E8 is 1 bit off E9. So I wonder if the flash is failing on this or something, but it seems strange how it's only in the bootloader where the problems are, because the other partition checked out okay when we ran the tool on it. I wonder if we could get my Pixoo out, take that apart and see if we can dump the bootloader or whatever from that one and then possibly program it into this one. So I've got my Divoom unit out here, and I think mine's a slightly different model because mine doesn't have the SD card like the other one does. So let's plug mine in a second. We've got the red light on there, but if you notice, mine comes up with a little fancy animation first, and once it connects to the Wi-Fi it should come up with things like my YouTube counter. So I'm going to take this one apart and hopefully we don't break this one. Let's remove this little board. So this one is slightly different because instead of the SD socket that the other one had down here, this one seems to have an eMMC instead. The rest of the circuit looks, actually no, it's different because there's only 2 MOSFETs here and the other one had 4. So it's slightly different, this board. So I'm not sure whether the firmware will work or not. I think we'll try connecting this one up and dumping it in any case. It looks like it's got the same TX RX ground and the same position for a switch here. So I'll solder a switch on, I'll connect the 2 wires up to the serial UART, and then we'll see if we can talk to this one and hopefully dump the flash from this one. So I solder the switch on this one, the same as what I did on the previous one, and solder the 3 wires on like we did on the previous one as well. So this is the board from my unit, which is connected to the serial, and this is the faulty one that has the SD card. So let's power it on and let's see what messages we get in putty. So I'll just power it up. Interesting. I think we're going to need to change the baud rate. But it's spitting out a lot different stuff, and it says chip boot revision 3. I'll just see if I can find out what baud rate this is supposed to be. So it appears the baud rate is 921600. So I'm just going to reboot it, and we'll just see what it does when it's actually booting up for the first time. Right, I'm just going to unplug it there a second. Just scroll back a bit. Right, so second stage bootloader. So this is the part where it seems to be crashing. And it gives us our partition table here. So that's handy to know. And it does things like checking the memory and that and stuff. But our other unit isn't getting this far, so I definitely think there's a problem with the bootloader. So let's see if we can dump the bootloader from this one. We'll save it as a file, and then we'll try and program it into the other one. And hopefully there's not too many differences and it works okay. So one thing I have noticed is my unit only has an 8 megabyte flash. So what I think I'll do first is I'll just back up the whole flash here, just in case anything goes wrong. So let's go to ESP tool. So we're going to back up the flash from 0 up to 800,000 here, and I'm going to call it something like my v2 good firmware.bin. So let's go back over to the unit here. We'll try holding down the little button I've added. We'll power it on. So that seems to be backing up my firmware, so I'll leave it to do that, and then we'll come back once it's done. And that's it, all done. So now we've got a backup of my firmware. It might be interesting to compare it with the firmware from the other unit. So the firmware from my unit starts with a block of FFs, and the corrupted firmware starts with all zeros. I'm interested in the bootloader part though, so let's see if we can go to that. Which is about this part here. So if we notice, my firmware starts with E9 and the corrupted firmware starts with E8. There's also a few other differences of like 1 bit, like that's a 2 and it's a 3 here. I mean, these firmwares might be slightly different, but if there's some obvious errors we can see straight away, like the B here on boot is missing on this side. We've also got partition, which is the J, which I spotted earlier. We've got table here, which is a D there. So I don't know what's caused this corruption here. Oh, there's another one that I missed previously. We've got mode here, and it's MO and then a $sign. So that's actually, is that 2 bits out? Because that's 24 and that's 64. Actually, no, that's 1 bit out as well. That's 1 bit out because that's 64, 65. So I don't know what's gone with this. Let's just see if there's any other differences. Well, there's a little difference here, but that looks acceptable because it looks like those were compiled at different times. It looks like this one was compiled at 6:30 in the morning and 31 seconds, and this one was compiled at 8:30 at night and 57 seconds. But a lot of this looks the same, so hopefully we should just be to extract the bootloader from this dump and then program it into this one. So I've been having a look through the hex, and it seems that the bootloader finishes around about here. And then we have the partition table starting at 8,000. So I think if we dump from 1,000 with 7,000 length. That should just bring us up to that byte here. So we're going to jump from 1,000 with 7,000 length, which will bring us up to 8,000. So let's just press the button again. So this is my good unit. And let's just see if we can dump this bootloader. That was quick. Excellent. Right, now let's connect the other unit up and then see if we can flash it. Let's press the button. We'll connect this one up and let's go over to the computer screen. And this should be the command I want here. So we're going to write flash at address 1000 and the file that we've just read from the other unit. So let's see what this does. Well, that was quick. So let's fire up putty now. And let's connect to COM6. And let's just reset the unit. Well, that's doing something now. Right, I'm just going to unplug it again. And let's just change the baud rate to the other one. Right, let's apply that. And let's see what it does when we plug it in now. Well, it seems to be doing something. So I think the next thing we'll do is we'll try it in the actual screen and we'll see if the screen comes on. Right, let's plug this board back in. I might just leave the little header connector on for the moment, just until we see what it's actually doing. It needs to go that way. Just make sure nothing's shorting out. Let's plug the power lead in. And put a little red light on, like we had before. Whoa, look at that. Yes! I don't think anybody's fixed one of these before. I've seen a few people that have had problems with them. Now it says connect. It'll not be configured for my Wi-Fi, so it's just going to time out. Right, I'll get this back together then. I'll see if I can get it set up. So I've got it connected to the internet and it's busy doing a firmware update. So let's see what it does after it finishes doing that. So I've got my original one here and the one that I bought from eBay. Now the only thing I've noticed is the one on eBay, there's a few of the pixels I think are starting to die on it, because this is an older unit with it having the SD card and mine doesn't have the SD card. So mine's a version 2 and this is a version 1. Well, I'll just show you what happens when we go onto the YouTube counter here. You can see some of these pixels here are actually lit up yellow instead of the white that they should be. There's another one there. So I think some of the pixels are starting to die on this one, but I suppose it is what it is. But at least it's working now, so we'll call this one a fix then.